Hello, I am Padma Mallikarjunan. I am an enterprise support manager at AWS, and I am based out of Austin, Texas. Welcome to AWS Knowledge Center Live, where we share best practices and troubleshooting tips from AWS Support. Joining me today is Aiden Bakirao and Mike Wells from AWS. Can you give us a quick introduction, Aiden and Mike?
Hello, my name is Aiden, and I'm a TAM lead based in Sunnyvale, California. I know as a TAM, every day, we work with customers directly to help them be successful on the cloud. And right now, a lot of customers are moving their workloads to Graviton2 based EC2 instance for the immense cost saving potentials. And we wanted to share some of those best practices and optimizations we're seeing. So yeah, over to you, Mike.
Hey, I'm Mike Wells, a technical account manager based out of Boulder, Colorado. And as a TAM, I get to proactively monitor my customers' AWS environment and assist with optimizations. Also coordinate access to programs and other AWS experts as needed. I started my career as a Java developer and was one for over a decade before I started TAMing. It was really fun to jump back into that development world and get some of these benchmarks. So, Aiden, let's kick it off.
Thank you.
Absolutely.
So today we're going to be talking about AWS Graviton2. We'll talk about getting started and performance optimizations for your workloads using Java and PHP. Before we get into the details here, a quick note to our attendees online. Please feel free to use the chat window on your right-hand side of on your screen and share your thoughts with us and ask your questions throughout the episode. We look forward to hearing from you. Aiden, over to you. Can you walk us through what we are going to be talking about today?
Yes, Padma. So just for a quick agenda, we'll go over exactly what AWS Graviton2 is and the benefits, why we want to input the effort here. We'll go over the development ecosystem and how to actually migrate and build multi-architecture containers. And finally, we'll cover some detailed examples with PHP performance increases that can be had by moving to ARM64 and similarly with Java. So over to you, Mike. Let's kick off here.
Okay, great. So let's take a first look at the Graviton processor. At reInvent 2018, we announced the first instances powered by AWS Graviton, the Amazon EC2 A1 family of instances. We were the first cloud to introduce a ARM processor as a cloud-based instance. These instances are optimized for cost and performance and are purpose-built for the scale-out workloads common in many modern cloud architectures. A1 instances are well suited for web serving, containerized microservices, ARM-based development and test workloads, especially CI/CD. We have these in bare metal as well as traditional. And A1 instances support up to 16 vCPUs and 32 gigabytes of memory, and up to 10 gigabits per second for networking, and 3.5 gigabits per second for EBS throughput. A1 instances are in 9 regions today, giving you global coverage for ARM instance types.
Excellent. So the A1s and the first generation of Gravitons was our first foray into custom EC2 CPUs. And with reInvent 2019, we announced the Graviton2 CPUs, which presented huge performance increases here. So you're actually seeing a picture on the left here of what an actual ARM, what a Graviton2 CPU looks like, with 64 vCPUs, 64 physical cores there, and 30 billion transistors compared to 7 billion in the A1, the Neoverse N1, I mean. And it had industry best practice or industry leading 7 nanometer transistors. So best technologies there. And what this really meant was 7 times greater performance, 4 times the number of compute cores. So that's 64 cores versus 16, 5x faster memory throughput, and twice the CPU cache. So this was a huge increase in performance, and you're seeing this with a lot of the extra adoption and performance numbers we're getting from customers that we'll cover shortly here. Go ahead, Mike.
Yeah. So the kind of key point that I want everyone to be able to take away is that you have great price performance with these ARM-based processors as compared to our current generation x86 based instances. We're able to offer the AWS Graviton processor in 3 new instance types. These Graviton2 based instances offer up to 40% better price performance over the x86 based instances. The M6G is well suited for general purpose workloads like the rest of the M series instances. And we also offer the C6G for compute intensive and the R6G for memory intensive workloads. These instance types are available now. They include local NVMe based SSD storage options, and every instance type also has a bare metal component, bare metal type that can be chosen.
And just before we leave that point, Mike, I wanted to call out just the velocity of new instance types coming for AWS. For example, we have the new T4Gs for test and development workloads, and all of these with the letter D variants with local NVMe storage. This is helping a lot of customers find the ideal instance size for their workloads, and it's just so great to see, an acceleration of new instance types available. But
absolutely,
let's drill into some of the performance results for applications that we're seeing, and so let's compare, with the previous 5th gen x86, the M5 instance types, and for example, on these database technologies, Redis, KeyDB, like we're seeing from 40 to 70% better throughputs, and like you said, price performance is really the massive winner there, and with for example, Memcached, 143 versus so 43% gains there. So fantastic results across the board, and we're just really excited to see these these gains here across the board. Over to Mike.
Yep. So these Graviton processors are being used in a wide variety of workloads across a huge number of customers. I know that your customer SmugMug recently had a migration over to ARM64, and Don McCaskill had a quote here about how they moved over to the M6G processor. It's been a really great cost saving for them, and I can't highlight enough how much, if you want to get high performance at low cost, the Graviton2 is a great option.
So Padma, before we jump into migration here, do we have any questions from the board, or yeah?
And quickly, thank you for sharing that GitHub link, Alex Smasha. It's a very useful link to getting started on AWS Graviton. So thank you for sharing that with us. Quick question for you, Aiden and Mike. I noticed on one of your slides, you mentioned custom AWS Silicon. Can you dive deep into what you mean by custom AWS Silicon?
Yeah, absolutely. So AWS acquired Annapurna Labs in 2015, and this started our whole journey into the custom silicon industry. And for example, with the Nitro hypervisor system, we had these special Nitro cards and Nitro security chips, for example, and later this led to the A1, the Neoverse N1 that we developed, and I have to give a shout out to one of my favorite reInvent videos from James Hamilton, I think in 2016, and that covers it in really good detail, all the custom silicon work that AWS is doing. And the real benefit here is when we're vertically integrated for the firmware, for the hardware, for the whole ecosystem, it has tremendous benefits that we can pass back to customers. So yeah.
Thank you. Yeah, let me grab that reinvent video and paste it here on the chat channel. And attendees online, feel free to ask your questions. We have experts Aiden and Mike here to answer all your questions on Graviton 2 based instances. Back to you.
Aiden, do you want to tell us a little bit about the Graviton software ecosystem and the kind of momentum that's generated?
Totally, Mike. So there is a ton of momentum in the software side. And starting with operating systems here, all the major Linux distributions and the BSDs, FreeBSD and NetBSD have support for ARM64, which is great to see. And the general consensus we're seeing here, because, for example, our server-based ARM64 CPUs are newer, we're seeing better user experiences and better performance results with the newer distribution that you do end up getting. So my advice there is to pick, for example, with Amazon Linux 2, we've done a tremendous amount of work to get optimized there. For Ubuntu, we're seeing, you want to start with at least 1804 and Bionic and move up. The later you can pick, the better results you'll get. And similarly with RHEL and Red Hat and CentOS, you want to be version 8 at least, and this guarantees better results across the board. So moving into containers, we're seeing for years Docker has supported ARM64 development and multi-architecture containers there, and also with the orchestration services, so ECS, EKS, it recently came out of a private preview for ARM64 in August, and also with the container registries, you can have both your app in the x86 variant and the ARM64 variant in the same namespace, same file naming. So that's fantastic to see, that ease of use for both container systems, including having clusters with both, a mix of say x86 instances and ARM64. And lastly, moving over to kind of the tooling and other software, you're seeing, the agents, for example, the AWS Systems Manager or AWS CloudWatch agent, having ARM64 support, and including some of the managed services like AWS Batch and the development ecosystems from Cloud9, and all of the CI/CD native code suite tools we have here, and including Amazon Creda, our OpenJDK versioning there. I also missed in the middle Firecracker for micro VMs. This will be, it's more for like Fargate and serverless, but this would be, you're going to be seeing more Firecracker in the future. So yeah, overall, a huge amount of momentum across the board, from OSs to the software, the tools you need to make it run nicely. And yeah, let's go ahead, Mike. Let's take it over to some more partner ecosystem here.
Yeah, we're seeing a tremendous amount of momentum with the larger software ecosystem to support Graviton. Here are a number of the other services and companies whose software is supported on Graviton-powered instances. This is moving so quickly, we don't have every logo sort of highlighted here, but everyone seems to be making a play and making a move into the ARM processor.
And so, Padma, do we have any questions from the comments there?
Yes, there is one question from AMR Raga B8080. I hope I pronounced it correctly. So this question is a recommendation on compiler frameworks that work best with Graviton 2. And also, are you aware of any optimized compilers flags? Is that something that you can recommend?
So for whatever language or tool sets you're using, I found the Getting Started guide on GitHub to have some tips and tricks there. In a lot of the cases, we're seeing software just working. For example, just using the latest versions of languages. But if you've highly tuned, like with the Intel compiler, you've highly tuned it, then I definitely recommend looking at the getting started guide for compiler advice there. I don't have any compiler advice off the top of my head, but I do recall it from the GitHub getting started guide, which I believe Alex pasted, and we'll cover it again on further in the presentation.
Got it. Thank you. No further questions on the chat window, so back to you, Aiden and Mike.
All right. So good segue. Just drilling into the languages and toolkits and runtimes here. Interpreted and compiled bytecode languages, they can run. Some of these guys can just run without modification. So that's really good news. It just works. Typically, just works. So we're talking like Python, Java, Ruby, PHP, Node, others, and same goes for .NET Core. So that's really good news. That's a really big chunk of modern software there. And compiled apps will need to be recompiled for ARM64. So every major compiler supports ARM64. That's the good news. There's more than a decade of developments in the mobile arena with ARM. So that's great that we have that. The whole community supports. So C, C++, Go, Rust, they all support ARM64. In terms for AMIs, the Amazon Machine Images, most major Linux distros, we covered this, are supporting ARM64 now for a few years. And, same goes for the tools and the SDKs and, like command line interface version 1.2, the agents, and furthermore, we have many SDKs that have the ARM64 support. And those work transparently. So, yeah, we got a good news overall there. So, Mike, why don't you take us into kind of stage one of migration then?
Yeah, the first step to migrate to Graviton2 is to identify all the software dependencies in your production environment. This includes standard and open source libraries, any proprietary binaries, or libraries, and any monitoring, logging, or security daemons or agents used in production. Once you've inventoried your software environment, which is an important thing to do regardless of if you're making a migration or not, check for ARM support of each one of your different dependencies. Many times there'll already be an existing binary or Docker images already built for ARM64. And if not, the vendor or provider may have some ARM64 support on their roadmap. You can also reach out to the Graviton team here at AWS. Their email address is provided here. They've told us that they love to hear feedback from customers. So if you want to reach out to them for support going forward, they'd appreciate that. Aiden, why don't you tell us about the next step?
So yeah, next step is really very similar to what you do with the normal application. So that's the good news. So, you need to test, you need to update, and you need to deploy safely. And, your test should support the multiple architectures, and these should be your automated tests, how you safely test your software today. And, your pertinent unit testing, acceptance testing, pre-prod testing, even performance testing makes sense. And what if you're updating your infrastructure as code? This is usually quite straightforward. You'd specify like a new AMI for the new instance types that you've updated, and leveraging CloudFormation or CDK makes total sense. And that's usually a faster, quicker change. And lastly, when you deploy, you can deploy blue-green methodology or canary testing, where you do send a percentage of your traffic to the new stack, monitor your error rates, your user behaviors, and keep an eye on your application health. So this is all very, very straightforward here. Mike, take over here for some of the container services, if you will.
Yeah, the container ecosystem on AWS has terrific support for Graviton2. EKS and ECS both support Graviton and Graviton2 based instances today. ECR supports multi-arc manifests, and code build can be leveraged to build container images for both x64 and ARM-based instances in parallel. Docker itself supports full multi-architecture toolchain through its new Docker X build command, which is going to give us the ability to build for either ARM64 or x86 with one code base. I think it might be cool to show the folks how this works.
Totally. So I'll just run through what I'll be sharing here, and let's start at the ground floor here. So if we want to create a multi-architecture container, we want to build for both architectures. I mean, why would we want to do that? You mentioned Docker's BuildX, for example. So most developers, still do some amount of local development, right? And most dev machines are still using x86 64 CPUs, and you still want to be able to interact with your ARM software and develop locally sometimes. So you get quicker testing if you're able to interact with both architectures. You can easily do benchmarking and comparisons between them, and you can easily optimize. And it also makes sense to have multiple architectures for your containers because of the instance diversification here. So if you're leveraging like launch templates in a fleet configuration, you can specify one x86 AMI and one for the ARM64 for the ARM instances, and this gives you like spot instance diversification opportunities. So and another reason I just thought of here is you can have you lower cost builds if you're building on ARM instances, for example, for IoT devices or you name it. So that can save costs there as well. Let me take over the screen here, and I can quickly run through a demo of us actually doing this. So cool. So I'm in my AWS console here, and I'm going to go ahead and launch a Graviton2 based EC2 instance. I'm going to choose Ubuntu 20.04 and hit the ARM64 flag, which filters the AMIs for me, and it filters to the Graviton2 based instances. Let's do an M6 G large, and just hit the defaults and SSH into this guy here. Let's wait a sec while it boots up. And here we go. All right, so initialized and launched. Let's connect. And what we're seeing here, I just wanted to walk through the steps to basically install Docker and the multi-architecture dependencies we need here. I'm quickly going to update. What the real magic we're seeing in these first steps is I'll be installing bin FMT support, and that's going to give me some extra binary format support for ARM64, and also I'll be installing QEMU, which will be allowing emulation to run here. And so I can emulate both architectures in once. And also I'll be the next command, I'm installing Docker.io, and also I'll be adding the Docker user to the Docker group, so I don't have to run sudo as best practice with my Docker commands. And just a quick reboot to make sure everything's baked in there. And we're progressing here. And the best part, I would say, of this is you can integrate this into any CI/CD pipeline if you're happy with this setup. If, for example, I know already our code suites, for example, code build, you can already do multi-architecture builds. But this is really what's happening in the background here. So for the next steps here, we're making use of I'll be grabbing just quickly getting jQuery, JQ, and I'll be getting the latest version of Docker's build X for the experimental builds. And this will allow the support for both ARM64 and multiple platforms. And great, so let's run this. Nice and quick. And let's quickly go ahead and run a Docker hello world. Make sure everything's running functionally here. All right, we don't have it locally, but it grabbed it from Docker Hub. Perfect, so hello from Docker. Let's go ahead and create the actual build container. And let's name that MultiArch build. And this is what we'll be doing the building of our application later. And let's use this build and quickly inspect this build here, this build container. So great, that works well. And you can see the platforms here, the multiple platforms it supports. We've got the ARM version 8 and the AMD 64 for architectures. And I can build for all of those. Let's quickly inspect a base image, the Alpine base image here. Let's make sure that it actually supports the platform we want to test today, and that it definitely does. Great. So we see AMD 64, that's for our x86 variants, and we do see ARM 64 v8. So perfect. I'm happy. I'll go ahead with the Alpine base there, and I'm gonna let's create a Docker file to kick off the rest of the steps, and let's start with that Alpine base image. I have a sample C app, just hello.c, that I'm going to be copying over, and that's going to be reading my architecture for me. So that's fine. Let's save that. Let's quickly look at the C app. So it's really just going to be printing the architecture that I'm running on to verify it definitely does work for us. Great. Let's save this. All in the local area. Perfect. And I'm going to quickly log in to my Docker Hub so I can push my image up once it's built. All right, I'm in. And as you see the build command here, I've specified two platforms, the AMD 64 platform and ARM 64. And I'm going to be tagging this as MultiArch 3. So you can specify more or less if you like, but that's what we're interested in. So let's let this run. And very straightforward, maybe 10, 15 seconds. And great. So all right, so that's run. Let's quickly, that's run successfully. Let's quickly inspect the images here. Let's have a look. So we're seeing, great. So we see the two images here for the different platforms, Linux, AMD 64 and ARM 64. And let's go ahead and just run that SHA. Let's go ahead and run one of these images. So we're expecting this to AMD 64. So running properly. Awesome. So at the last hello my architecture, we're seeing x86. Let's go ahead and do the same for the ARM 64 image, verify that is working. And we're seeing, great, ARC64, which is equivalent to ARM 64. So perfect. And another thing we could do from the other direction is test this on my local machine's dashboard, so on my Docker, local installation of Docker. So I'll go ahead and quickly run this, and I'll pull this from Docker Hub first. All right, 1 minute ago, 2.8 megs. And cool, we got this. Now let's quickly run this. Awesome. And we're seeing it's successfully running x86 64 Linux. So Great. Yeah, that's the quick demo here of building your multi-architecture containers. It's really straightforward. Just a couple of plugins and modules, and we're off and running. So great. At this point, let's go ahead and jump to back to the slides here. Padma, do we have any questions from the comments here?
We do. Thanks, Aiden. Very, very informative demo. A few questions here for you. So first, there's a question from Alex Smasher. In general, can you talk about AWS Graviton2 support for AWS services? And the specific question from Alex is about Fargate.
One more time, please. Sorry.
Can you talk about AWS Graviton2 support for AWS services? We support them for code build currently today. Do you have any information about Fargate?
So good question. So as far as I know, it is not specifiable in Fargate today. But given the support for Firecracker, the micro VMs, and behind our serverless, I believe that that is a future something to support. And the overall trend is more and more AWS services are supporting ARM64. For example, RDS, I believe, was a week or two ago. Elasticache previously, EMR a few days ago or weeks ago. It's just growing. So. But yeah, look forward for that in the future.
Thank you. A couple more questions here. This question from AMR Rag B8080. So, and the question is about ML inferencing. Can you talk about ARM as it pertains to ML inferencing? Now, I know that IoT Green Gas, our service, where you can run ML inference locally, and I can paste a link to IoT Green Gas, but specifically about Graviton2 and ML inferencing. Do you have anything else you can add to that, Aiden?
I think I've seen a lot of our customers, using Inf1 instance type, Inferentia, AWS Inferentia. It's the Inf1 instance type, and they've been seeing huge performance gains there, even compared to using GPUs. And I don't recall any extra work being needed to be done for prepping for ARM64 on this. So if you're bringing your models over, PyTorch or MXNet models, that's I do not recall any extra ARM64 work for this. But definitely check out the Inf1 instance type for inferencing.
I'm going to try and get that link and post it on this window. Just one last question, because I know you have two more exciting demos that we want to get to. Question from MR Builder 10. How do I calculate my new vCPU limit? Any guidance on that?
Mike, did you want that one?
I'm not. I can tell you that that each vCPU is its own core instead of a thread like on its x86 instances. As far as actually calculating the need there, I might need to research that a bit and get back to you on that one.
Yeah, perfect. So what we would do for that is MR Builder questions that have not been answered. I'll provide a link at the end of the show. It's our AWS forums, and we will get back on that if you post a question. So Mike and Aiden, over to you. Show us the next two demos.
Yeah.
Great. So next, I just wanted to cover, how, like we talked and we showed, how to actually get started with multi-architecture containers. We've shown, that synthetic benchmarks have big gains on multiple applications like Redis and Memcache, et cetera. But we wanted to actually talk about, and look at an actual real-world benchmark, which, really popular PHP as a standard, content management system. And we wanted to put some load. We wanted a system under test to show you what, how you can actually improve performance of a pretty popular workload out there with some various changes. And the design here is we have a load generator, WRK, doing the HTTP requests as fast as it can. We have a system under test, which is 95% CPU usage, running WordPress with an Nginx fast CGI web server, and lastly, a separate EC2 instance running MySQL. And the instance in the middle will be running the M6G instance type. And the software changes I'll be showing here are multiple versions of Ubuntu, of PHP 7, and each of these incorporates over 10 changes, such as improvements from AWS, such as patches to the Zend optimizer, memory allocator changes, and removing legacy constructors from like PHP 4, for example. So let me grab the screen here, Mike, and I will drill in here. So first thing I wanted to highlight is an amazing blog from Sebastian Pop, our colleague, senior software engineer, that covered this in great detail, way more than we could cover in like 5 minutes here. But what I would be basically replicating is his blog here and just showing some of the enhancements he has here. And for example, Zend framework, we helped work with Zend to get the Zend optimizer working for it. This is the exact same setup test here with different versions of Ubuntu and PHP, including the PHP 8 coming in 2021. We showed 30 to 40% performance increases here with all the contributions that AWS has made. And this is great. The scalability of PHP, meaning Mike mentioned vCPUs. One vCPU is now a core, which means near linear scaling. So this is fantastic. What you're seeing in my console here is the multiple you're seeing the multiple different EC2 instances that will make up this test. The separate MySQL instance, the Ansible script server that I'll be kicking all these off from. I wanted it to be repeatable and easy to run, and do duplicates of the benchmarks just to average out. This is, I'm just showing us the benchmark YAML file for work, and you're seeing like 16 threads, run length of 1 minute each, with 256 connections. And this will be, all of this is in one EC2 placement group, just to eliminate like network noise and variability. And I'll go ahead and start off with the slower, the older distribution of Ubuntu here, 1804, which is still quite new. But this will go ahead and run. These are I'm using Ansible scripts to just automate this. And, best practice, maybe you run this as like a nightly build for your test, performance testing, see if there's any performance regression. But next, I'll go ahead and kick off a separate build, a separate Ansible run here for the Ubuntu 20, which will also include PHP 7.4, which is the current latest PHP. And cool, let's kick this off. This is recorded, so this is about, it'll take like 10-15 minutes, so I'm just going to quickly like fast forward here. But we'll have these running side by side and just compare the performance results here. And as this kind of, let's see here, finishes up, we're definitely expecting the later versions of Ubuntu with all the improvements here to show up faster. So as expected, Ubuntu 18 took 15 minutes of real time, and Ubuntu 20 took 12 minutes. But let's drill into the actual run IDs and analyze how many requests per second and how much throughput we had here. All right, so let's log back in. Let's go ahead and find our output files. All right, that's my run ID. Each one's coded separately, and I'm doing this manually just to show us the, exactly what's involved in this pipeline here. And Also, these are on 3 separate EC2 instances to also remove any variability of the database resource contention, stressing it out there. So we just wanted to focus on the exact results here. So looking at requests, let's have a look at requests per second. We're seeing on the bottom here 832 requests per second average. So we'll take that as our baseline. And let's go ahead and do the same for Ubuntu 20 and compare there. So awesome. We're seeing like probably around 30% delta here. We can find exact figures, but that's a huge gain. And already the M6Gs are faster and cheaper than the M5s. And coupled with the software benefits here, let's go ahead and compare this. So like 832 with our Ubuntu 20, PHP 7.4, we're seeing, 30% approximately. I could do the math shortly. The next change I had a hint that opcache, had an effect on performance here, because in the earlier PHP versions, it wasn't as optimized. It was all very focused on the Intel x86 optimizations there, and so I wanted to go and disable this, and as it's enabled by default here. So I'm going to put this into my Ansible script here, and just go ahead and replace that in the PHP INI configuration. Let's paste that right before it restarts the PHP. And all right, cool. So let's disable. Yeah, perfect. That looks good to me. We're going to go ahead and disable opcache there. So opcache, what it really does is it stores the compiled PHP code in memory, which is usually very helpful, but it wasn't optimized at first for ARM64. Let's go ahead and see what performance difference that this would have. Let's let this run. And with every subsequent version of PHP, the community support has grown tremendously to make ARM64 more optimized. So we're seeing 13 minutes and 22 seconds of real time. So it looks like it's somewhere in the middle, but let's actually go ahead and drill into the results there for run ID AF2. All right, where am I? Let's see. All right, a lot of runs here. And looks good. Okay, let's pop it open and find our request rates. All right, so as suspected, it's somewhere in between here. So just leaving it enabled with the default configuration is actually giving us better results than disabling it. So if we pop this in here, we saw a 31% increase by moving to the latest Ubuntu and PHP version. But if we go ahead and take a look at what that changed here, that gave us like -5%. So it makes sense to leave opcache enabled in this sense. So great, yeah, that's just a really quick benchmark demonstration here. We're seeing really big performance gains just by using the latest versions of PHP there, and without even extra tuning that are needed there. And I definitely want to send us back if we're interested in more details, and including like over 10 AWS contributions we've made to PHP 7.4 and what to look forward to in PHP 8 Master. Check out this blog here, and yeah, and let us know what you think. So great. Let me stop here. Let me hand it over to you, Mike, for the Java section here. Thank you.
All right. So I did a good bit of digging into the Java performance, and there's several different things that we can look into for improving Java performance. Some of the biggest hit items that I saw right to begin with were upgrading the JDK version. We first started supporting the JDK first started supporting ARM processors in JDK 8. Since then, up to JDK 11, there's been significant improvements on running on the ARM architecture. There are some kind of deeper tunes that you can do. Some OS distributions on Graviton2 use 64 kilobyte pages instead of the standard 4. So some heap tuning can be required for that. I'm not going to dive into that with this demo. I'm going to talk mostly about comparing the OpenJDKs 8 and 11 and Corretto 8 and 11. I'm going to talk about using parallel garbage collection, which takes advantage of the cores that are running in the AMD processor to be able to run garbage collection across each one of those different cores. And I'm going to talk a little bit about bias locking. If your objects are locked by only one thread, bias locking in the JVM can make an optimization and bias that object to a thread so that subsequent atomic operations on the object incur no synchronization cost. So Aiden, if you want to pull up, share your screen there, I'll talk folks through this demo.
Totally. All right.
So we're going to be using the SciMark2 benchmarking for Java to begin with. This just runs a series of like Fourier transforms and Monte Carlo simulations and kind of taxes the CPU a bit. I'm going to start off. You can see that I have some M6G instances running here already. I'm just going to walk through how you start up an M6G instance. I'm going to be using Ubuntu 20 to start, but this is also available in the Amazon Linux as well. Be sure to choose 64-bit ARM there to be sure to pull up the ARM-based processors. As I mentioned, we're going to be running the M6G large to begin with. And I've already launched these, so I'm going to hit the configuration details, but I already have 4 of these launched and kind of pre-baked in the oven, so I could just pull a cake out and show you guys here to begin with. The main tunes that we're going to make, as I mentioned, are going to be around the JDK itself. I've installed Corretto 8 and Corretto 11 on 2 separate instances, and I've installed OpenJDK 8 and OpenJDK 11 on 2 of these instances. And let's jump into those and SSH over into these boxes and run this SciMark test. This SciMark test is pulled directly from that website. I did take out some classes that were around SWT, I think it was SWT or whatever the actual GUI portion of things are, so I could run this headless. So this one is the OpenJDK 8 version that we have here. Like I said, on these other instances, I've put, sorry, this is the Corretto version. And we also have Corretto 11 installed on another. Oops, looks like I didn't put the correct directory here. Let's go into the right directory and run this. So this output displays from SciMark. It displays in megaflops, but I'm running it as I'm going to put the time command in front of each one of these different commands whenever I run, to see the actual time that it takes to run these simulations. These simulations also do they run several times. It runs the Fourier transform and the Monte Carlo simulation and these things several times in a row to account for clock drift. So we get an average of the times based on these runs. Let's see on this one, so we can see, and each one of these runs around 30 seconds to actually do the processor. So here we're going to change use bias locking. And as I mentioned earlier, that just if a thread locks a variable, this reduces the synchronization cost across threads. Again, taking advantage of that fact that we're using separate cores for this. And lastly, I'm going to run in parallel GC, and that lets the garbage collection run on different threads. I'm going to pull up here after I make this run here. I built a spreadsheet to be able to show the various timings for each one of these, and kind of show what kind of performance gains we can make. Let's get this last one run and pull up the Excel. And that one. Aiden, if you want to just zip up to the end here in the interest of time, looks like we're getting pretty close here. It'll we can see the Excel where we actually compare each one of these different. Okay, here we go. So as you can see, upgrading to JDK 11 can and also using parallel GC and unbiased locking can give you a 4% boost. I think with further tuning and application-specific tuning, we can get up to probably 6% on this as well. So those are that's kind of just like a tip of the iceberg as far as improvements that can be made on going through tuning some of these Java things. So I think that if you start to dig in deeper, I'm sure if any of you have done performance optimizations before, it's something that you can sort of really get into and sort of really lose yourself in. So it took a while to get to these types, but I think for your application specifically, the main points are upgrade to JDK 11, and parallel garbage collection and unbiased locking are kind of your two biggest hit changes. You're gonna swap over to the slides and let's wrap things up.
Totally.
Thank you. Thank you, Aiden and Mike, for sharing your knowledge today. So everybody, today we discussed performance optimizations for your workloads using AWS Graviton2 based instances. We looked at performance optimizations using Java and PHP, and hope today's discussions help you to design high performance applications. If there were questions today that were not answered, including the vCPU limits question, please post your questions on forums.aws.amazon.com. And email us feedback. We want to hear from you. We want to hear what you liked about the show and what else you would like to see. Our email address is kc-live@amazon.com. Thank you for joining us today at AWS Knowledge Center Live. Happy cloud computing.
Thanks a lot, guys.
Thanks, everybody.